Hi. Braille Slate Reader is a tool enabling you to convert scanned Braille pages, in JPEG image format and written with a Braille slate, into Braille Ready File, or BRF, digitized Braille enriched text format, or RTF, documents, complete with formatting elements such as alignment, paragraphs, underline, italics, bold and strikethrough, basically allowing you to include any formatting encoded by RTF commands or Braille typeform indicators. A neat functionality of Braille Slate Reader is that the typos, sequences of at least 2 successive full Braille cells, automatically get filtered out, and do not appear in the final RTF text nor in the BRF file. The BRF file can in turn be used to print out copies of your work on a Braille embosser, or to read them electronically using a refreshable Braille display. My deep learning model for the Perkins Brailler along with a dataset and other useful information may be found on my Google Drive at the following link. The model is also available for download on this GitHub repo. Also check out my other GitHub repo eBraille Tales for a similar OCR application with the Perkins Brailler. Dependencies and limitations. This Python project relies on the Fast AI deep learning library to generate a convolutional neural network deep learning model, which allows for Braille optical character recognition, or OCR. It also needs OpenCV to perform image segmentation, to crop the individual characters in the Braille page images. When writing text on the Braille slate, unless a space is included at the end of a line or at the beginning of the next line, the last word on the line will be merged with the first characters on the next one, up to the next space. Funnily enough, this is illustrated in the thumbnail above, where you can see that I forgot to put a space in between A and slate when writing on the slate. As such, the line continuation without space Braille symbol is not required and should be avoided, as it could be confused with other Braille characters, such as initial letter contractions. However, line continuations with a space can be used without problem in this app. In this application, a space needs to be included after any RTF command, even though the RTF specifications state that it is an optional space. The reason for this is that when the code is transcribing the Braille into printed English, it often needs to determine whether any given Braille character stands alone. A Braille character that stands alone means that it is flanked by characters such as empty Braille cells or dashes, but not by a Braille character mapping to a letter or number, such that can be found at the end of every RTF command. In other words, you must include a space after any RTF commands. Here is an example. This requirement, \strike, strikes, \strike 0, me as being important, which in Braille would be written as follows. Importantly, the pages must be scanned in landscape mode, with the left margin placed on the flatbed scanner in such a way that the shadows produced by the scanner light will face away from the left margin. The shadows will face the right margin of the page, when the page is viewed in landscape mode. This is because the non-white pixels actually result from the presence of shadows, the orientation of which plays a major role in image segmentation, determining the X and Y coordinates of the individual characters, and OCR. For best results, the Braille document should be typed on white Braille paper or cardstock, and scanned in landscape mode as grayscale images on a flatbed scanner at a 300 dpi resolution, with the paper size setting of the scanner set to letter, 8.5 by 11 inches. The darkness setting of the scanner might also need to be adjusted to achieve an optimal Braille shadow to noise ratio. When scanning the Braille pages, care should be taken to close the scanner lid slowly, so as to avoid moving the page, which could result in misalignment and subsequent segmentation issues. To ensure that the segmentation has proceeded adequately, the segmentation result image, scanned image overlaid with green character rectangles, for every scanned page of the Braille document should be quickly inspected. These images are generated by the code and stored in the page image files with rectangles folder, which is created automatically by the code. The slate must be calibrated, meaning that the number of horizontal pixels between a dot in the top left Braille cell and its corresponding dot in the top right Braille cell, in landscape mode, see figure 1 for more on this step, needs to be passed in when running the code, preceded by the horizontal _pixels : argument. The same procedure needs to be done for the vertical dimension of the slate that is within the frame of the scanner in landscape mode, by passing in the number of vertical pixels after the vertical _pixels : argument. That is to say, you must provide the number of pixels between a dot in a top corner, and the corresponding dot in the lowest cell, on the same edge of the slate, that fits onto the flatbed scanner in landscape mode. Additionally, the number of columns and the number of rows that will be visible on the scanner in landscape mode need to be provided, after the slate_calls: and slate_rows : arguments, respectively. Finally, the X and Y pixel coordinates of the center of the top left dot of the top left Braille cell need to be passed in when calibrating the slate, after the top underscore left underscore X underscore pixel colon and top underscore left underscore Y underscore pixel colon arguments, respectively. See Figure 2. When running the code, it will provide you with the number of horizontal and vertical pixels in between Braille cells that has been calculated using the above information. However, you might want to fine-tune the calibration step by increasing or decreasing the value of horizontal underscore spacer underscore pixels colon and vertical underscore spacer underscore pixels colon that were calculated by the code. Simply pass in your numbers of choice after these arguments when running the code, and check the scanned image overlaid with green segmentation rectangles to see if there are any improvements. Adjust the value of these variables until the green rectangles line up nicely with the Braille characters on the image. The code will then remember these optimal parameters for the calibrated slate, which are stored in the default underscore parameters folder, which is created automatically by the code. Naturally, should you want to use another slate, you would need to back up the calibration data for your first slate, and then perform calibration on the new slate, as described above. Figure 1. The illustration above shows the different parameters, in addition to the number of rows and columns, that need to be passed in when calibrating the slate with some of your text, with full Braille cells in the corners. In my case, running on a Linux system, hence the Python 3 in the line below, I needed to pass in the following arguments when calibrating the slate: Python 3 space, BRL-Slate-Reader.py space, open quote top underscore left, underscore X, underscore pixel, colon 351, close quote. Space, open quote top underscore, left underscore, Y underscore, pixel colon 2348, close quote. Space, open quote horizontal, underscore pixels, colon 2603, close quote. Space, open quote vertical, underscore pixels, colon 1530, close quote. Space, open quote slate, underscore calls, colon 36, close quote. Space, open quote slate, underscore rows, colon 13, close quote. Figure 2. The X and Y pixel coordinates of the center of the top left dot of the top left Braille cell need to be passed in when calibrating the slate, after the top underscore left, underscore X underscore, pixel colon and top underscore left, underscore Y underscore, pixel colon arguments, respectively. The GIMP software allows you to find the Y and X coordinates in the lower left corner of the window. Note that the Y coordinate shows up before the X coordinate, as the page was scanned in landscape mode. Make sure to always load the paper on a flat surface, in order to properly line up the page in the slate, with the hinge to your left and the Braille cell windows opening away from you, and the other side of the page reaching up to the hinges. You also need to always position the sheet of paper in the same way on the flatbed scanner. This will ensure that you will achieve reproducible segmentation results when performing OCR with your calibrated slate. When filling in the Braille cells containing mistakes, make sure that there is at least one adjoining full Braille cell next to the correction, as otherwise a single full cell would be interpreted as 4 in the RTF document, and wouldn't be removed from the BRF file. It is also good to know that erasing mistakes with a Braille eraser often leaves grooves on the page that are picked up as dots during the OCR step. I would then advise you to simply use at least 2 consecutive full Braille cells to mark your mistakes. Getting started. The following instructions will be provided in great detail, as they are intended for a broad audience and will allow to run a copy of Braille Slate Reader on a local computer. First, click on the code drop-down button at the top of the GitHub repo and click on Download Zip, in order to download the compressed working folder in zip format. Extract the folder in your desired destination, then access the Braille-BRL-Slate-Reader-main folder and select its contents, and cut and paste them into your working folder. Delete the empty folder and the zip file, and head back to the README file on the GitHub page. The instructions below are for Windows operating systems, and while I am not 100% sure that it is able to run on Windows, I made every effort to adapt the code so that it would be compatible, but the code runs very nicely on Linux. Start by holding the Shift key while right-clicking in your working folder, then select Open PowerShell window here to access the PowerShell in your working folder and enter the commands described below. Step 1. Install PyTorch, required fast AI library to convert images into a format usable for deep learning, using the following command, or the equivalent command found at this link. pip3 space, install space, torch vision space, torch audio. Step 2. Install the CPU-only version of FastAI, which is a deep learning Python library. The CPU-only version suffices for this application, at least when running on Linux, as the character images are very small in size. Pi space, -m space, pip space, install space, fast AI. Step 3. Install OpenCV, Python library for image segmentation. Pi space, -m space, pip space, install space, OpenCV Python. Step 4. Create the folder OCR raw data in your working folder. mkdir space, OCR space, raw space, data. Step 5. You're now ready to use Braille Slate Reader. Usage. The Braille Slate Reader Python code converts JPEG Braille text scans into printed English, in the form of a rich text format, or RTF, document, and digitized Braille as a Braille Ready File, or BRF. In addition to the RTF and BRF files, the code will generate a Braille text file, .txt, containing the OCR results before transcription into printed English, so that you could revisit the text in Braille form. Each page of this text file will line up with the pages written on the slate, and will be separated from one another by 2 carriage returns, to ensure easy navigation throughout the document. You can find instructions on how to use Braille Slate Reader on my YouTube channel. In order to submit a scanned Braille text page to the code, you will need to place the JPEG image in the OCR raw data subfolder of your working folder, which you created in step 4 of the Getting Started section. Should multiple JPEG images bearing the same root name be placed in the OCR raw data folder, for example, scan.jpg, scan1.jpg and scan2.jpg, the OCR prediction results for each page will be added in sequence to the correspondingly named scan.txt file, within the scan subfolder of the OCR predictions folder. Should you ever want to repeat the OCR prediction for a set of JPEG images, it would then be important to remove the scan subfolder before running the Braille Slate Reader Python code once more, in order to avoid appending more text to the existing scan.txt file. Then, once the calibration step has been performed as described in Figure 1, you could simply run the Braille Slate Reader Python script by opening a PowerShell window in your working folder, and entering the following command. Pi space, BRL-Slate-Reader.py. The first thing that the code will do is perform image segmentation, determine the X and Y coordinates for every Braille character. The segmentation results are visible as green rectangles overlaid onto the scanned image, in the Page Image Files with Rectangles folder, which is created automatically by the code. Upon inspection of the green rectangles, you might wish to fine-tune the horizontal and vertical spacing in between Braille cells, such that every green rectangle would frame their Braille cell nicely. Simply adjust the value of horizontal underscore, spacer underscore, pixels colon and vertical underscore, spacer underscore pixels colon until you get satisfactory results. The code will keep these optimal settings in memory in the text file found within the default underscore parameters folder. You should make a backup of these optimal parameters, and maybe add a label on your slate with these values, so that you wouldn't need to repeat the calibration step in the future for this slate. When running the code with a different slate, you would either need to calibrate it, or replace the default underscore parameters.txt calibration file, if present, with the calibration file that you created previously for this other slate. It is possible to resubmit the Braille text file to the Braille Slate Reader Python code once you have made modifications to it. The Braille text will be extracted from the text file and the carriage returns that were introduced to facilitate proofreading will be automatically removed by the code, if still present. Simply place the corrected text file in the OCR raw data subfolder of your working folder and include the name of your text file when running the Python code, as follows. Pi space, BRL-Slate-Reader.py, space open quote, my text file name.txt close quote. When providing Python with the name of your file, and placing the text file in the OCR raw data folder, the OCR step will be circumvented and your Braille text will be converted into the RTF and BRF files. You can continue this process until all mistakes have been dealt with. The following RTF commands are automatically converted into BRF tags by the code and are transcribed from Braille into English RTF commands in the RTF file. The Braille equivalent of the tab RTF command, \tab, will be changed to 2 successive spaces in the BRF file. A line break RTF command, \line, will be converted into a line break, \n, in the BRF file. New paragraph RTF commands, \par, will be mapped to a line break followed by 2 successive spaces in the BRF file, as new paragraphs in Braille documents typically begin with 2 empty Braille cells that serve as a tab. Similarly, in the RTF document, any Braille new paragraph RTF commands will be switched to \par, \tab to add a tab at the start of every new paragraph. The page break RTF commands, \page, are changed for a form feed tag, \f, in the BRF file. New section RTF commands, \sbk page, will result in the creation of several BRF files, one for each section, which will be placed within a BRF folder within the OCR predictions subfolder under your file name. For an in-depth explanation of all the most common RTF commands and escapes, please consult the following link. These are the only RTF commands that are automatically removed from the Braille text and converted into BRF tags. All other RTF commands, if present, will be carried over in Braille form into the BRF file and could be removed manually afterwards. However, as Braille already encompasses typeform indicators for symbols, words and passages written in caps, italics, bold, underline or script, font size of 28, as well as symbols in superscript or subscript, there should be limited need to resort to other RTF commands than those listed above. When using grade 1, or numeric, indicators, these should be placed directly in front of the characters they will be affecting. The next order of priority is the capitalization indicators, followed by the other typeform indicators, bold, italics, underline, script, and finally by superscript or subscript indicators. And that's it. You're now ready to convert your Braille manuscript into digital format. If you are close to someone who is visually impaired and would like to help them find meaningful work through technology, or maybe if you are only sprucing up your Braille skills in preparation for the zombie apocalypse, lol, then this app is for you.